Good afternoon. I'm going to talk about using models in consumer neuroscience. And yes, this is how we get started. Yes, my talk will consist of 3 parts. A part in which I will explain what consumer neuroscience is and why it's, let's say, sensible, has a place in the market. Then I'll talk about my company, Neuroscience, what we do and how we got started. And then I'll talk a bit more extensively about predicting the success of commercials. So let's start with consumer neuroscience. If, in general, if you explicitly ask subjects about their future intentions of purchasing stuff, it's not a very good indicator of what they will actually do. What you see on the right-hand side here is a overview in which other factors like economical development and stuff like that have been regressed out. And after you take into account general population variations, you see that there is very little left of reliability in explicit report of subjects. Now, there's this false psychological view of human behavior, and none of you share this view, that we have this conscious access to why we do stuff, and that we know the base for our behavior, and if neuroscience teaches us anything, and by necessity also, we cannot know a lot of the fundamental, let's say, things that motivate our behavior just because so many stuff is going on in our brain all the time. There's just so much in the world going on, there's so much that needs to be updated and considered in the past. Most of this needs to go automatically. So from that perspective, it's not that strange that there's this not optimal correlation. But this is a failure in a basic assumption of classic predictive market research. Now, I'm not claiming it's not sensible to ask subjects about what their behavior in the past. In general, people, if they bought a big car, they remember. And they can report about this quite reliably. Not necessarily their motivations, but definitely the actual past behavior is reasonably reliable when you ask subjects. Now, there have been now in the last 15 years a lot of studies that actually show that it's possible to predict consumer-based behavior of an entire population on the basis of all sorts of different measures. I guess the best is MRI. So this is an example of a study by Burns from 2011. And in this study, 27 teenagers were listened to lots of different songs that were going to be released into the market. All of these songs presumably were deemed to be potentially successful because releasing a song is costly. And they were reasonably well. I mean, it's not brilliant. It's a correlation of .32, well in predicting the success of sales. And specifically, they were really good at, not shown here, in which songs really were not getting any traction at all. And so this is a nice example of using just 27 teenagers to predict the purchasing activity of the entire United States. Another example of such a study is from 2018 by Simone Koens. They showed, this was a nice ecological study. It's always difficult to get good purchase information. This was regarding, let's say, the in-store advertisement for Duplo chocolate. And basically, they showed all of these different variations on the Duplo chocolate on top of basically a stack of Duplo chocolate. And then the question was, which is the best? One question you can wonder is, does it have any influence at all at buying Duplo? And the other question you could wonder is, what is the best? Is one of them actually better than any of the others? And then you can, of course, ask subjects. So what's going to be the most effective board? And then here you see the most effective board according to the qualitative interviews. This is the least effective commercial. And this, using bold MRI, was the prediction from bold MRI. Now, of course, the golden measure here is actual purchase behavior in store. And using the actual purchase behavior, you got this ordering. This coincides. So there are 2 big conclusions here. One conclusion is that apparently advertisement works. And depending on whether you put this on top of the Duplo stack or this on top of the Duplo stack, people buy more or less Duplo. It could have been that there was no effect whatsoever. There were differences in purchasing behavior. And then they also presented a formula. They took the nucleus accumbens twice, the orbitofrontal cortex twice, the amygdala once, the hippocampus once, some other areas. They've inserted this into a formula and they claimed a correlation of .94. So when this paper hits the market, one of my researchers came in and said, we should use this. And then I said, no way, this is an a priori model. It's not going to happen. This must be a post hoc fishing expedition. Of course, you can predict something with a post hoc fishing expedition. Ignoring that, there have been many papers that have been published linking brain activity to successful prediction of consumer behavior. So I would say that there's this clear case and use for using, instead of, let's say, explicit interviews of subjects about what they're going to do in the future, more implicit types of research to try to determine what is more and what is less efficient ways of communicating. And then why is let's say, explicit research still going on, still being used? I'm guessing that because there are some correlations. I mean, it's not that you get no information whatsoever. But if you look at the type of research being done and the type of, let's say, predictions that are successful, it is that explicit research gets you the bounded behavior boxes. So in general, you can ask something about where's the bounded behavior, but within the bounded behavior, you're not going to get much of a reliable prediction. So, Neuroscience, what we do and how we got started. So, in 2009, an MR scanner was placed at the Psychology Faculty of the University of Amsterdam, as the first part of the Spinoza Center Amsterdam. And of course, there was this business plan, and this business plan presumed that it would generate an enormous amount of income. We did not make the business plan, but there it was. And we founded Neuroscience in 2011, in the first case just to increase the customer base of our scan center. And today, Neuroscience is a company focused on consumer neuroscience, neuroeconomics, and the perception of, let's say, how people experience environments. And we use a multitude of methods: MRI, EEG, eye tracking, rapid implicit association tests, even questionnaires and interviews to answer questions for our customers. And we also advise customers on how to increase the effectiveness of their commercials. We are not only active in the Netherlands. This is an overview of a site where we conducted research. Yeah, a lot of traffic in the last couple of years. Be nice. Well, one of our big products is, let's say, advertisement testing. I'll get back to this in the third part of the talk. So, in general, what we do is, well, we have a model, we measure MRI activity, and then we try to predict, well, this ad is going to be effective or less effective, and also, not uninteresting, why we think this ad is going to be effective or not effective. And what we also do with our television commercials, we do a lot of ad testing, and this is an example of ad testing that we did for Philips. What you see here on A is a advertisement for a iron, apparently the most powerful iron. Well, we tested it. It didn't come out as that great as an ad. Does anyone have any idea what's wrong with this ad? It's a very psychological thing that's wrong with the ad. Sorry? Could be, yes, but yeah. More psychological. Can I see how many people are right-handed in the room? This is not how you grip and so just switching around the iron also according to our measurements improve the ad. And that's kind of nice that people making ads are not psychologists. Even just inserting some psychological knowledge into this process can improve the ad campaign. Also, we've done a lot of experiments. We have some sort of idea of, like, this is going to work better, this is not going to work better. But often this is connecting, let's say, neuroscience to psychology, and well, not much more than that. Another thing that we do is we do pricing research. This is where we usually, for this we use EEG, and for this we use this nice mismatch signal between a price and a product. And this actually works really well. We field tested this also quite a lot, like how to determine the optimal price for a product. If you see a product associated with a certain price and you have an entire range of prices, you can actually pick up larger or smaller mismatched signals with EEG. And clearly the smallest mismatch is in general, or would be our prediction of the optimal price. I also do some consultancy. This is one of my favorite jobs that we ever did. The ad is in Dutch, but I'll translate a bit.
Zou je een orgaan van een ander willen als dat je leven zou redden?
So the voice says, would you want an organ from someone else if it would save your life?
Ja, tuurlijk. Ja, ik zou willen blijven leven. Ja.
Maar ben je zelf al donor?
Oops. And then the woman says, yes, sure. I would like to live. And then the interviewer asks, are you already yourself a donor?
Nee. Nee. Klinkt een beetje stom, hè?
And at the point we said, no. Sounds a bit stupid. And this ad, when they changed their ad campaign from what they had before that to this, they saw an increase in people being confronted with this ad in space from 1.5 to 6.1 conversion rate for donorship. And then basically what we were hitting for is that it might be more interesting to refer to self-interest than idealism. And that worked. We also just replicate research to see, well, does this work, does this doesn't work? So to get back to our Kuhn study, when Walter, the researcher, said we should do this, and I said, no way this is going to replicate. So we tried to replicate this, and that's actually a lot of work because you need a combination of a brand, someone who owns the brand, and lots of different shops. But we got that with Yogi Tea. We ran in 4 stores, 4 different tests. So then this is the Yogi Tea, and then we placed either nothing on top of this to get an idea of the ad space. It could be in the original study that actually there was negative influence and positive influence, and there was no all-over influence of the ad. So that's why we had a nothing, and then this is what Yogi Tea originally was advertising with, and these were 2 productions that we made ourselves. Now, according to our bold MRI research using the Kuhn formula, of which I was utterly convinced that it was not a priori decided and selected by the company, if you look at, well, what's actually working better, we saw that actually this has 10% more sales than this, and this actually has a couple of percent more sales than that. So, shockingly enough, flabbergasted, that formula worked. And the reason probably why that formula worked is that in general it's not that difficult with MRI signals to outperform explicit reports or, in that sense, experts. And again, does anyone have an idea of why this is working better than this? Because at least there's a good post-hoc narrative for this. You see someone drinking tea here. And so, in general, something that we pick up and that we also see back from literature is that if you see people doing stuff, and then that's apparently much more positive than just having a general sign, at least for consumer products. So that's roughly what Neuroscience is and how we got started. So how do we predict the success of commercials? Well, of the past 9 years, we've collected now 5,000 hours of MRI recordings with, different types of communication material. And somewhere in the 3rd year, we decided that it would be sensible to have this well annotated. We have this pipeline now, this predefined pipeline. We optimize it over time, so every couple of months we update it. We show television commercials or advertisement material in general. We record from, in general, 24 subjects. We get brain activity in a segmented network. From this, we extract, at this moment, 16 different networks, and then we look at the activity of those 16 networks. And how did we construct this pipeline in general? Well, these networks we generated first by, well, this parcellation is a cortical region of interest parcellation of small cortical regions of interest. Then we look at the patterns of activity within the regions of interest and the connectivity pattern between the networks, and then on that we just do unsupervised clustering. And at the moment, and then you get this arbitrary cutoff. There's nothing fancy there. There are different ways to do unsupervised clustering. All of them will do roughly the same thing. And then we get something like, at the moment, 16 different components. These components we then use for labeled data. So we have labeled data from how effective different commercials are. That's an industry data factor. How likable commercials are and how annoying commercials are. And then if you have that, if you have, let's say, 16 activity levels and 16 times 16 connectivity profiles, it's very easy to just do some grid regression and you have your model. Then the question is, how well is this model working? Well, this is a high-level output of the model. So you see here for 2 different balances, personal appeal and positive versus negative, that effective commercials have the tendency to be here, annoying commercials have the tendency to be here, and likable commercials have the tendency to be here. And if we look at the actual classification, we see that we are, for the effectiveness of a commercial, what is the most important for a marketplace area, very good in predicting the effectiveness of a commercial. And if we make a mistake at all, we say that non-effective commercials might be effective. Now, once you have a model like this, you can use it for a multitude of things. So, in general, when people make an advertisement, a company orders an ad, and they spend maybe, let's say, $1 million or $2 million or even more to generate the ad, and they have this tested, and you say, it sucks, you shouldn't broadcast it, that's not going to happen. This doesn't work within the decision space of a company. You can't post hoc say, there are too many, the wagon is running. So it's more interesting. So post hoc, you could give some advice of maybe you could recut stuff, or this works better, or maybe you should go for this framing. But there's not that much to do. And more attractive it would be to, in a conceptual stage, already decide this is going to work or this is not going to work. And then the question is, can you use a model based on real-life stimuli? Can you, let's say, also do this in the concept stage? So we did actually quite a lot of research into this. We we took existing commercials with, let's say, known effectiveness, and we had all sorts of different ways to sketch back these commercials, to get, let's say, dummy versions of these commercials, which are relatively cheap to make. And at the end, what we now have is a model that at least reliably has a good or steady correlation with, let's say, this concept testing versus these real things. So what we're trying to, let's say, generate as a, let's say, interesting way of doing this ad stuff is that you should generate multiple concepts, select the best concept, and develop further from that, versus just using this intuitive idea of, oh, this is supposed to work better or not. Finally, we've been working on temporal evolution models, and MRI has lots of temporal information. It's just being squished out over time, so if you just have enough labeled data and a smart enough model, you can predict stuff in time. And we can do that now relatively well. I'm going to show an example of something that we recorded in, I think, last year in New York. What you're going to see is the temporal valence balance. So if things go up, it's good. There are, let's say, there's in general more positive or actual reinforcement type signals, reward type signals, and when it goes down, there are more, let's say, signals that at least correlate to what subjects subjectively report as negative feelings. And what we see, what is a strong predictor of commercial success, is that this balance is okay. There's other stuff also, but it's an important balance. So let's look at this commercial, which is English.
Kathy's gotten used to the smell of lingering garbage in her kitchen. Yep, she's gone nose blind. She thinks it smells fine, but her guests smelled this. Febreze Air Effects Heavy Duty has up to 2 times the odor eliminating power to remove odors you've gone nose blind to. Use Febreze Air Effects till it's fresh, and try Febreze Small Spaces to continuously eliminate up to 2 times the odors for 30 days. Febreze Small Spaces and Air Effects, 2 more ways to breathe happy.
So what we see here is we kind of understand here. We see the moment that, let's say, this nasty trash can is introduced, a couple of seconds later, a couple of seconds later, we see a drop in the, let's put it there. We see a drop in the activity. It gets back. There's a solution being provided. You get back to this, let's say, this positive signal. And then, again, in general, something that we think that they should have cut off the signal, the advertisement here. I'm not sure whether they did. Probably not. But what they do here is introduce a second product. So that it might sound, let's say, like a cost-effective thing to do. I have one product, and why not tag on a second product? We then, in general, see that there's this decline in effectiveness of the commercial. So, I hope to have shown you that with the current state of bold MRI analysis, it's possible to use these in an effective way to evaluate, understand advertisement and communication material in general. Thank you for your attention.